there's some definitions we need to look at before we can talk about it. First, I want to tell you what a factor is. Anybody know what a factor is?
No.
All right, let's do it. What is it? What is it? You know?
Numbers.
It's a number.
Keep going.
It's a number related to another number. Yeah, right.
Sounds good to me. Let's try to put it in one way. Let's say numbers that, I can say related. I'm going to say numbers that multiply. Numbers that multiply. To equal a product. All right. Numbers that multiply to equal a product. For instance, 35 is our product. What numbers can we multiply to get 35?
5.
5 times what?
So,
That's right. So 5 and 7 are factors because these are the numbers that we multiply to equal what? 35. What's another way to get 35? There's always one sure way to get. Well, when I'm talking multiplication, well, 0 times something.
You mean 35 times 1.
There you go. So 35 times 1. So the factors of 35 can be 5 and 7 and 35 and 1. All right. So factors, numbers that multiply to equal product. On our multiplication sheet, the factors of 14 can be 7 and what? And 2. All right. The factors of 33 can be 11 and what? 3. All right. So the factors is what's found in this highlighted area here. Product is what's found in the middle. Now, so factors. You know we're going to be talking about numbers that multiply to get something. So that's our factorization part. Now we got to talk about prime. All right. Let's see. Who in here used to shoot dice before they were saved? Yeah, okay. Now, we got saved, shoot dice. All right, now, we used to have a saying that said breaking somebody down to their prime. What they mean? What they mean when you say that? If I'm breaking you down to your prime, what I mean by that?
Taking everything.
Taking everything you got till you ain't got nothing. All right. All right. You can't leave with all the money. You got to sit there and play some more. All right. Now, prime is defined as, let me get an easier way of saying it, is, let's say, a number greater than 1, a number greater than 1, a number greater than 1 that has factors of 1 and itself only. I missed that word, self. Only 1 and itself. That's how you know something is prime. So for instance, this dime is not prime. Because I can break that down a number of ways. What's one way you can break down a dime? 2 nickels. What else?
10 pennies.
10 pennies. I can do 5 pennies and what? 1 nickel, right? So that's not prime. Why is the penny prime?
You can't break it.
You can't break it down anymore. Okay? So what I mean by that is this. A number other than 1. Let me see this. Is 1 prime?
Yes.
What did it say?
No.
All right. So this can be prime. 1 is a unit. So it's not prime. All right. What about 2?
Yes.
2 is prime. Because the only way you can get 2 is what? 1 in itself. All right. The number 5 is what? It's prime. Yep. And you can only thing that can give you 5 is 1 times 5, right? Okay. Now,
So,
Uh-huh.
all numbers other than 1 is prime
No.
number?
It has to be other than 1, and you can't have any other factors
Oh, okay.
but 1 in itself. It got 2 parts to it. Now, the only thing, well, we have a term that's, when something's not prime, it can be something else. It could be composite. All right? It can be a composite number. This is a number other than 1 that has factors other than 1 and itself. It got factors other than that. So if I look at 4, we know that 4 is 1 times 4. But 4 got something else that'll give you 4 too, which is what? 2 times 2. All right. When I look at my timetable chart, I see 4 here, and I see a 4 over here. This line is 1 times everything, but when I look past this right here, these are my other numbers. 4 is 2 times 2. Everything in here and down is composite, because they have more than the factors than 1 in itself. So, a lot of people say, well, all the odd numbers are going to be prime. That's not true, because 9 is not only 1 times 9, but 9 is also what? 3 times 3. So 9, even though it's odd, is a composite number. Now, there's something we're going to use. What I want you to do now is, on your timetable chart, I want you to circle 2, 3, 5, 7, 11, 13, and it's not on here, 17, 19, 23. These are all prime numbers. If you get a 2, 3, 5, 7, 11, 13, 17, you can't break them down anymore. Everybody else, you can.
What was the last number?
I got a 19 of 20. I said 23, but these are all your prime numbers. I like to circle them, because what we're going to do next, your answer can only be prime numbers. All right? So circle that on your paper. Give yourself a little hint when you're doing your work. Now, we're going to practice this in a minute. All right? Now, in prime, so now we know prime and composite, or we have seen what those definitions are. We got to talk about a factor tree. A factor tree is when you break down a number until it's in its prime, until you have nothing but prime factors. So let's take 36. So when you write the number, that you're breaking down, you put 2 legs underneath. All right? One leg is going to be one factor, the other leg is going to be another factor. What 2 numbers you want to start off doing 36? You cannot use 1 in itself.
6.
All right? 6 times what? All right, so 6 times 6. Now, based on my chart, are these prime numbers? So I got to keep breaking it down. All right? So I can break down 6, right? So if I go to 6, 6 down here. 6 is 3 times what? All right, you knew that. All right, so we're going to break down the 6 to 2. This is the first thing that's going to be on your test. All right, 2 times 3. We also can break down this 6, right? 2 times 3. Now, the prime factorization of 36 is how many 2's? 2 2's, so 2 dot means times, 2 times 2 times 3 times 3. All right, now look what didn't happen. When I told you what my factorization was, what the prime factorization was, when I gave you only the tips. If you give me change for a $10 bill, will I still get that $10 bill back?
Yeah.
If you give me change for a $10 bill, you gonna give me 2 5s and the 10 back?
No.
Why you not?
You asked for change.
You broke it down for me already, right? So when you're doing this stuff, when you break down a number, you can't give it back to me. You're gonna only give me what you broke that number down into. Now, let's look at here. When we get to the end, are 2s and 3s prime? It is. So we are done with 36. I know I'm right because 2 times 2 is 4. 4 times 9 is most definitely what? 36. The way you write this in exponential form. How many 2s do we have? So you say 2 to the second power. Exponent means how many of those numbers you have. So 2 to the second power. How many 3s we have? So we have 3 to the second power. That's how I want you to write this right here down. All right? So what I want you to do is, we're going to practice now. I'm going to walk around and help people that need some help, but the ones that got it. So for the people that need help, you can watch me. Okay. I'm going to put a chart out there for you. If you got it, you go ahead and roll. All right. These are divisibility hints. Where Miss Boyd gone? Let me see what's going on. If you need some help, stay with me. I'm gonna give you a chart to help with this. What you do is, first thing, check the digit. Check the last digit. Remember, you can use your notes on the test. So check the last digit. Draw your line. All right. If you check the last digit, if the last digit is even, if even, what do I mean by even? What's the even number? What we got? Yeah. If it's even, you got 2, 4, 6, 8, and even 0. If your last digit is even, then 2, underline 2, is a factor. All right. Let me show you what I mean by that. Let's take the number 76. All right. Let's take 76. Look at the last digit. Is it even? So what's a factor? 2. So you draw your 2 legs and you put 2 on one of them. Now in your cell phone calculator, to get this missing 1, what's 76 divided by 2? Go and put that in your calculator. What you got? 76 divided by 2. You got to practice with me so you know what's going on. What's 76 divided by 2? What you get?
38.
38. So that's your missing factor, 38. Now, we look at the last digit on the 38. Is it even?
No.
Is it one of those digits?
Yeah.
You see it?
Yeah.
All right. So 8 is even. So we draw the other 2 legs, and 2 is one of the factors. Divide 38 by 2. What's our missing factor?
15.
Say it again. Say it again.
19.
Yeah. All right. 19. Now, 19 is prime. Add that to our little list on the top of our paper. 19 is prime. So we should have that. We said 13. Where my little paper at? Add 19 to the top of your paper, to our prime list. So you know if you get 19, you can stop. All right. Mine somewhere. But add 19 to your paper. So the prime factorization of 76 is 2 times 2 times 19. Those are the prime factorization of 76. Now, you can also write 2, how many 2's you got?
2.
So 2 to the second power, and you can get a 119. I like it, I'm gonna give you credit for both, but I like it looking like that. So if you check the last digit is even, you know how to break it down.
So that's the answer. We ain't got that solved.
No, because you go back, you're gonna go back to 76. All right, so here we go. All right, let's keep going. So that's how to know if 2 is a factor. I got 3 more tricks. So for the people that's working, keep working. For the people that's with me, stay with me. Next thing you can do is add all digits. Give you another hint. Add all digits. Now, if the sum is a 3-time table, what's your 3-time table? What is it? Give me a few. If you get any one of those numbers, 3 is a factor. Alright? So if you add up the numbers and you get a 3-time table, 3 is a factor. Alright? Let's try it out. 123 is my number I need to factor. Now, let's look at the first rule. Does the last digit even? Is it a 2, 4, 6, or 8? It's not. So we can't use 2. Add up these 3 numbers, what you get?
6.
Is 6 a 3-time table? So that means one of your legs or one of your factors is 3. Just add up the numbers. Now, how do you find out the missing factor? But you can put it in your calculator. You're going to divide it, right? What you put in your calculator?
About what?
123 divided by 3. What's your missing factor?
41.
How much?
41.
41. There you go. All right, now, 1 is not even. So we can't use 2. And what's 4 plus 1? That's not a 3-time table. So you stop. Your answer is 3 times 41. That's what we're going to use. All right? I can do another one. What if the number was 111? All right? That's not even, but what's 1 plus 1 plus 1?
3.
That's a 3-time table, right? So 3 is a factor. How you get the missing factor over here? What you do to these two numbers? What's it, the 111 divided by 3?
33. Yeah. Wait. 30.
Put it in there, what you get? You got 20, it should be 37?
Yeah.
That's a 37, all right? And that's what we got going. 3 is a factor if you add the numbers to get a 3-time table, every time. All right? I got,
What question you said? What you trying to do?
1, 5, 8, and 12. All right, here we go. I got 2 more hints for y'all. 2 more. That way you can use these notes and be straight, because you're going to use this throughout radicals, fractions. We use this all the time. So here we go. If the last digit is 0, if the last digit is 0 or 5, then 5 is a factor. If you know one factor, you divide to get the other one. So for instance, for the number 415, don't worry about how big it is. Look at the last digit. Your last digit is what? So 5 is one of your factors. So in your calculator, what you gonna do to get your missing one? Sinclair?
5 divided by 4.
No, do it back. Do it the other way.
415 divided by 5.
All right. What you get? 83. And because 3 is not even, and 8 plus 3 is not a timetable of 3, you stop. Your answer is 5 times 83. Pine Bluff, you good?
So what you do for the 0 to 0?
Shepherd, you good?
Yeah.
Talk to me. You getting stuck?
I forgot what number you said to do.
Oh, you don't need none of this? You don't need none of this? We got one more now.
Can you do number 140?
140?
Oh, wait, that's the question?
Who? What's wrong? Where? Well, who 37? Where am I? Right here? Yeah. 37. Alright? Last hint. And then we're going to work on, I'm going to walk around while we work on this other one. Last hint. Alright? Now, y'all know this one. Are all digits the same? Are all digits the same? Alright? It's almost like that. If all digits the same. Alright? Now, if you got an even number of digits, That means you got 2 digits, 4 digits, 6 digits, 8 digits. 11 is a factor. All right, 11 is a factor. For instance, 66. These are they the same digit, they're the same number, and you got 2 of them. That means 11 is a factor. And if you want to know what the missing one is, 66 divided by 11 is what? 6, right? We're not done. Because when I look at 6, 6 is even. So, 2 is a factor. 2 times what is 6?
3.
3, alright? And our factorization of 66 is 11 times 2 times 3. You always write your prime numbers down. Alright? So let's look at this. Let's look at that. With the hints that we got, let's pull up our worksheet. Let's put that back on the screen.
With the worksheet, because you're on paper, right?
Yeah, on that same paper. Yeah, all your notes go together. Don't never separate.
Oh, the worksheet not a work? It's just
Yeah. Yeah, just practice. Yeah, just practice. Alright. Let's look at 34 together. Alright. According to our chart, that last digit, is it even? So what's one of your factors? Finish it up for me. Finish it up. I'm gonna come check you out. That's all it is. What's the 2 factors you got? 2 times 17. That's all you're gonna get on that. Go on, finish them.